Hello, everybody. My name is Rafał Ślusarz. I'm a CEO at Genies.it, and it's a great honor to have the capability to talk to you guys today at the Flutter Summit about quite an interesting and hot topic, which is code generation in Flutter. I'm pretty sure that everyone already tried a bit with it. And the reason for this talk is relatively simple. I would like to talk to you about how we are using vibe coding in a way that provides a reliable and a production ready code to our customers, which is what we're doing right now at Genius IT. So, without further ado, I would like to talk to you about, or actually show you this process that we delivered and developed at Genies based on our last development, which is the Marry App application that we built for one of our customers. This application is a moderately complex app, which is meant to help people to plan their weddings. Although we're not going to focus too much on the functionality itself, but rather let's just talk how complex the application really is. So, this app has at this very moment AI integration that is meant to generate basically the content of this application, right? So we are generating the checklists, timelines, budgets, but we're also reviewing the preparations as they go. So there is a functionality where you can just ask the model if everything is going as expected, right? The application also has support for notifications where you get an information that, for example, you should do something until today or until tomorrow, and it's better you do it, right? Or we have integrations with the cloud. We have support for accounts and subscriptions, right? So overall, it is a moderately complex application. With our estimations that we also did internally, we would probably work on it for 2 to 3, probably 4 months of an actual traditional development, right? But with an AI code generation, we were able to build a production ready application within 50 hours roughly. We get these data because we are strictly monitoring our process right now. So we got exactly the reading that we were basically spent exactly 4 hours on pure code generation. So this is the amount of time that Coursor.ai was processing our prompts and generating code for us. It was just 4 hours. We spent additional 24 hours on the code review and manual work. So first of all, we were reviewing the code that we got from the AI code generation, and we were either fixing stuff that were not as up to our liking, we were updating documentation, or we were doing stuff that we were not really expecting AI to be good at. There were also some stuff that we needed to do for the store release fixes, especially when it comes to the subscriptions. But roughly speaking, 24 hours of an actual development work where we were doing something in the code. Then about 12 hours of setting up the store presence. So we're doing it for the customer account, so it was also quite important to do this, properly. And about 10 hours of refining requirements. Although here we're not talking about refining it with the customer itself, but it's the process where we are creating and modifying the functional documentation of what actually has to be done. So, in other words, roughly 50 hours of billable work for a developer to deliver this kind of the application, which is production ready and the customer already likes it and builds the business upon it, right? So today's presentation is meant to show you how we actually build a process that was able to provide, giving us the capability to build something like that. So the core functionality or core idea for this process is that, of course, we are using an actual LLM code generation. I've already mentioned that we were using Coursor.ai for this project, although at Genies AI we were also using Windsurf. Though For the sake of this presentation, I will be talking about the Coursor.ai, but every single element I'm going to mention is transferable to other IDEs, AI code-driven IDEs. So we can actually expand it or move it to other IDEs to our likings as well, right? Uh, but getting back to the main topic, the idea for our work is roughly based on the assumption that LLM AI code generation is nothing else but a mid or junior developer in our team. It's even more than this. It's an army of of very motivated, very efficient mid developers. But we know that it's our job right now, developer's job, is not just to be a developer, but it's to be more than this. It's to be a product owner, it's to be a team leader. So we are expecting right now that a developer has to be able to feed the LLM with three types of data. First of all, Flutter rules, which is basically how the code has to be written. Then we have docs knowledge base, which is nothing else but where do I get a proper source of information? And the third thing, which is the feature documentation, which is basically what has to be built in the bigger scope as a whole scaffold of it, not just within the prompt, but in the bigger picture, what has to be done. If you think about it, it's exactly the same thing that you are telling your developers in your team whenever you're onboarding new people, for example, or whenever you just build a team. These stuff have to be told to your team members, and there is no reason not to tell that to the LLM, right? On the right side, of course, we get a code that is produced, but we also have a feedback loop here, which we call a session retention, which, as a matter of fact, is nothing else but to make sure that whatever we produced, uh, which is not only just the code, there are some decisions made by the LLM that are not digitalized, that are not written anywhere. We are trying to make sure that we keep this in the future. So future sessions, future agents that might be also different agents will be able to pick up the work and continue. Which, if you think about it, once again, is nothing else but of mimicking what actual human memory is, right? You're expecting that your mid developer is able to pick up the work exactly what it started, where it was left, or can discuss with other developer that is meant to take this job over. So that's basically what I will be discussing in this session. So before we start, I would like to make sure that one thing is also clear here. So um, let's just discuss what kind of a tool LLMs actually are, right? Because I'm pretty sure that every one of you either seen this kind of the article or heard someone doing this kind of stuff, where people are just asking LLMs, for example, who will win Premier League next season? And they are actually expecting that ChatGPT did some sort of a thorough reasoning, took all this stuff into perspective, and really delivered an answer that matters, right? We all know it's not what it is, right? Because LLMs are not nothing more than just, I know, I really like this metaphor that LLM is just like an alien that landed up on Earth, has literally no idea what it means to be a human being, any kind of a context of what kind of existence it has. But it literally consumed all the knowledge from the internet and is very good at calculating probability. So whenever it's asked a question, it can calculate what is probably the most appropriate answer. And that's it. It's a powerful tool, but it has a lot of limitations coming out of it. So you can expect that the LLM will be exactly as I've already announced, your trusted mid developer minion, but you have to understand that every single time you can expect it to deliver at 80% precision of what you wanted, 80 to 90%. And it's your responsibility to, first of all, feed it with the data to bring this closer to this 90%. And also, it's your responsibility to deliver these missing percentages that are still left. So, in other words, it's pretty much the same setup as if you're working in the team and you are a senior working with other developers. You have to make sure that you can utilize their potential in a proper way. That's exactly the same thing with LLM. So, without further ado, we've already discussed that we need to somehow feed these. How do we want to write a code? And what it actually means is that you, as a Flutter developer, experienced Flutter developer, you have to digitalize your own knowledge. In Coursor.ai, there is a functionality called project rules, where you can feed it with MDC files that are meant to store these informations. If you're not familiar with that, I put a link to Cursor directory website. There's also a QR code to it, where you can find already existing and shared by community members files, Cursor files for Flutter and a set of other technologies as well, which is nothing else but it's kind of this kind of a prompt engineering where you get the first line being like, you are an expert Flutter developer, you know block, you know go router, and these are the set of rules that you have to go through. So, for example, you are not overusing stateful widgets. You are making sure that you're properly managing the state according to the documentation. And you can set up different linter rules as well. But what it actually is nothing else but a convention, because despite the fact that there are some mistakes that you could do, but to be honest with that, you would probably get that out of the Flutter documentation itself. But there are some conventions that you want to impose on your team within this particular project. So, for example, you would like to make sure that we are using block as the state management, we are using go router as the for navigation, that we are using provider and not riverpod or the other way, that we would like to have some sort of dependency injection, that we want to use code generation for routes or not. There are many different decisions that you have to take within the project and make sure that this is imposed in order to make sure that the code is written in one way and thus is maintainable. So this is exactly what this file is. Though I want to make sure that no one is really tempted to just do it in like one evening on a couch and just think about every single solution and just try it, write it down, because it won't really work. The best way to think about it is, once again, you're mimicking this kind of a way of work with the LLM as it is with your team members. So we have the way of communication with our team members through the code review. So do the same thing with your LLM agents within this file. So whenever you get a chat prompt and you're reviewing the code and there is something that you don't really like, you're giving a feedback to the chat and you get a fixed version. Every single time, ask a chat for a Cursor rule that would make sure that you're preventing this mistake in the future. So you are having this kind of a cycle of learning the LLM within your way, how you want to make sure that the code is written, right? It's basically exactly the equivalent of working with the code review and making sure that your mid developer remembers that for the future this kind of a mistake shouldn't happen, right? So that's basically it. Digitize your own knowledge. The next step is, as we've said, you have to tell your team always what kind of a source of knowledge, what is a reliable source of knowledge. So you would, for example, like to make sure that whenever there are some snippets for using the block architecture or especially Go router, it's taken from the proper source and not some sort of thread and Stack Overflow. In order to do this, you can actually link documentations to Coursor.ai in a way which is relatively just, it's simple. You're just pasting the link and that's pretty much it. Then this documentation can be indexed. And with that, you can first of all refer to it within creating a prompt, but also you can expect that the LLM that you're using within the AI agent will be able to use these documentations as well in order to generate a more accurate responses. That's basically this kind of one of the most important tricks to make sure that you're getting from 80 to 90% of accuracy of what you are actually requiring, right? And the third useful thing to feed your LLM with is what we call a feature documentation. What that actually is, once again, is nothing else but telling your mid developer, not only within every single prompt, just create the home screen, just create the login screen, or anything like that. It's rather like onboarding your mid developer and telling him, okay, so this project is a wedding app, right? We are making the application for example, a game. We're making e-commerce application. there will be these kind of actors, there will be these kind of functionalities. This document is meant to be more or less a scaffold, an overview of what this application is for. The reason is that if you don't do this and you're just expecting LLM to rely on your prompts, first of all, you can't take benefit of models like Gemini 2.5 to really just fire and forget and do a lot of stuff for you, especially when it comes to big functionalities like navigation or creating already full list of models that your application will need and properly documenting it, right? Because there is no context and your application doesn't know how to do it. One additional thing is that if you don't have this kind of the documentation, you are unfortunately vulnerable to the situation where your application, where your LLM might start creating duplicate code and basically just get lost on the stuff that were already created before, and the logic wouldn't be reusable. So that's once again, it's yet another element that basically brings cooperation with the LLMs as with an actual team member to let him know what this project is about, right? Um, with that, we covered what are the inputs that we're using for the LLM. So once again, digitalized knowledge on how to write the code, actual proper sources of knowledge when it comes to the documentation, and three, a proper document telling the LLM about the overall idea about what this project is about, right? So then we can actually get the code generated, but we are still having the issue with the session retention. I'm pretty sure that most of us already had the situation that we were very happy with the session. We created a lot of a great code, but for example, right now we would like to change the agent. We are not really happy with how the agent copes with this current task, for example, or we are just tired and we would like to continue tomorrow with pretty much the same pace. So the thing is that AI agent, exactly as a human being, take some sort of the conscious decisions while creating the code. Not everything will be documented within your NDCs. So, for example, there might be a decision on how to structurize the model, and it might not be really reflected in the code this way. There might be some sort of thought that you're just missing. With an actual human being developer, the developer will get back to the work next day and will still remember it. And if someone else is meant to work on it, the developer will know that this is important information. It will just share it with your developer, for other developer, right? LLM is not able to do it, and we need to have some sort of the mechanism that will be able to retain this session and this kind of knowledge. So for that, we actually talk about a solution that is basically containing two stuff. First of all, the architecture summary document. It might be one document, it might be a set of several documents, but the thing is that this is a document that is meant to be a single source of truth for the for the decisions when it comes to the architecture. It will probably it's a good idea also to document every single file that you have in the application with some sort of a simple comment. In other words, basically it's meant to be a document or set of documents that is then consumable by the LLMs in order to retrieve the context and understand what was actually built, right? And the second thing connected with the session retention mechanism is proactive and continuous documentation mandate. You have to make sure that you are creating this kind of a cycle that whenever you're creating a prompt, chat prompt, and the code is generated, you are making sure that the AI agent will not consider an actual feature or prompt finished until the code is properly documented. This way, you're creating this kind of a cycle, which is just proactively generating these documentations for you, and you don't have to think about it, right? So, in other words, session retention is nothing else but asking the AI to not only generate the code, but also document every single step in the concise. So you have this kind of the essence of what these changes were for, which is then easily understandable by humans, which is probably one of the best AI code review tools for people. So you can actually review the code in the bigger batches and do it actually much quicker. This is actually what we're doing, but also for the other AI agents to make sure that they can pick up the pace and go continue an actual good work. So that's the theory behind session retention. But let's just talk about how to actually implement it. So within Coursor.ai itself, there is already existing functionality called cursor memories, but this functionality at this very moment is in beta and it's disabled in privacy mode. Although it's worth mentioning and reading about it, because what it actually is that it makes AI agents to create artifacts which are meant to be these memories, like developers' memories, that I took some sort of the decision here and it's not really reflected in the code, and put them as an artifact into your repository, right? um, we've tested this functionality already, but once again, I'm not really recommending it for a production code, especially taking into consideration that you have to disable the privacy mode, which might be a blocker. But it's worth noticing that this functionality exists and just monitoring how it goes, because it has a major potential. Though, as for now, you can actually, in order to implement this kind of the idea, you can look for Cursor's memory bank phrase on Google, and you will see several guests on GitHub built by other developers who have a relatively mature way of building these kind of session retentions. Usually, there are suggesting set of different files to retain the information, and also some sort of the prompts to be put into particular cursor rules files to make sure that this cycle continues, right? But basically, you can also try it yourself to write your own prompt and see how it works for you, because at the end of the day, it's all about how you're creating your prompt and how you're creating these kind of the function prompts and requesting functionalities. So I'm pretty sure that it's not deterministic. There is not like a objectively the best way to do it. So it's probably worth checking it and seeing what works for your team in particular. With that, I would like to finish the idea of the process itself and the particular elements within it, and talk a bit more about the details, which are always probably the most important. So when it comes to some sort of the tricks and tips I would like to have, is that um, I believe that we need to choose our models wisely and understand these models. Exactly as it is with the team leader, you have to understand what are the weaknesses and strengths of your team members, because there are models that are great for something and not really great for other stuff. So, my typical setup usually, I'm widely using three models mostly. So for my everyday work, I'm usually going with the Claude 3.5 Sonnet, which is a very good model for everyday work. It's very good with well scoped tasks, so relatively small tasks and one that are properly documented. It often needs guidance, which I actually kind of like, because it's making sure that it's not going too far with thinking and just hallucinating, but it's just making sure that everything keeps more or less concise. So I really like it for already existing code bases that I work with, and I'm just trying to make some sort of adjustments. But it's not very good. It's actually terrible, to be honest, when it comes to working on large features or early developments where you basically have a clean code base and you want to deliver something, or the customer decided that they want to change something and you're trying to work on a refactor. For that case, I'm usually going the Gemini 2.5 Pro, which is an extremely good model when it comes to it, with especially with the thinking capabilities. You can literally just fire it and forget for quite some time when it's reading the functional documentation, understanding what has to be done, and for example, building the navigation stock for you. It's capable of building all the different models that you would need in your application, also with the documentation later on that you would need. So it is really good for that. Although, as I have said, it's usually very easy going to for with the reasoning too far, probably too far that you would like for just a simple solutions. And also, it's not very good at understanding deeply what the code is meant to do. So, if I'm actually encountering some sort of a complex bug that I don't really understand even myself how to fix, I usually like to go with the O3, which is a model that is very slow, but it's very good at understanding complex bugs and complex features, right? So this is my understanding of how these models work. I'm pretty sure that you can have your own based on your own experiences, but once again, it's worth understanding how your models, how your trustworthy mid developer minions work, so you can then choose an actual agent for a proper work, which is also connected with custom optimization. Additional idea that I want to sell here is that it's worth thinking about building your own packages. Because once again, if you have AI code generation tools, you are almost like having your own small software house. So you are building a code base very, very fast. And it's worthwhile to make use of it. So you can also ask in Flutter rules the AI agent to try to build code in a way which is reusable, so you can create your own documentations later on. And instead of building the same code over and over again, for example, for outs 2, or maybe you have some already existing functionality for a complex widget that you really, really like and you want to reuse, that's the thing that probably should ring a bell, that you don't have to reinvent the wheel and build over and over the same code. You can think about building the set of reusable code for you already, right? Especially as plugging in the documentation to your package to Cursor is very, very simple, right? And writing this documentation is not a problem whatsoever, right? At this moment with the AI. So it's something worth mentioning. Additional idea that we've learned is that it's really worthwhile to allow LLM to help you automate literally everything. LLM is very good at writing the scripts, and if you're using Fastlane, then you can easily save yourself a lot of time by incorporating store listings directly into your code base, which by the way is great because you can then get these listings delivered by, for example, Gemini 2.5 right away based on what your features are. You can get changelog properly done as well. With Match, you can get certificates generated within the code as well right away, which is also very good and very helpful because you don't have to set these stuff yourself, and many other stuff like generating icons, splash screens, and stuff. Fastlane is not the only automation tool, but definitely something that we're using at Genies.it, and I definitely recommend it, especially as taking into consideration the idea of creating the packages. You can also create already existing scripts for Fastlane and put it into the template of your application. So definitely something worth mentioning. Uh, as a last item I would like to cover is we should probably also think about when LLMs are a good solution and when they are not, because people tend to think that LLMs is just a silver bullet, and that's pretty much where I want to emphasize why we need to be mature and trustworthy leaders for the LLM agents in order to achieve success. Because if you would ask even the Gemini 2.5 to add integration to Firebase, in most cases it will, in some cases it won't, because at the end of the day, it's probabilistic. It won't always produce exactly the same outcome. There are documentations for Fastlane, of course, right? And you would expect, yeah, just follow the documentation. But your project might vary, and some other stuff might cause the fact that it just won't do the proper job, but already mess up your code base, right? And why do you even bother if there is an actual Firebase CLI, which basically with one line of a code does exactly what you wanted in a proper deterministic way that you can trust? The same thing comes to, for example, editing dependencies. LLMs many times try to add stuff to your pub spec, like new packages if they're using it, just by adding additional entry, which usually causes the thing that um, it might hallucinate and, for example, add the dependency with a version number that doesn't exist, or with a version number that is not compatible. Why do you even bother if there is an actual terminal comment, flutter pub at dependency, which works perfectly fine and makes sure so that everything works and is properly, compiling later on. So these stuff can be added to the Flutter rules to make sure that whenever there is a proper tool, use this tool. And it's just about coaching your model to make sure that it does what you're expecting, right? So I guess that's the good note to finish with, because at the end of the day, this whole presentation was about how LLMs are good at generating the code. And here we were telling quite strictly that we need to know, once again, limitations of these LLMs. So we talked about limitations at the beginning of this presentation, and we covered it at the end as well. With that, that's it of what I had today for you guys. Once again, thank you very much for having me at the Flutter Summit. It's always a great pleasure and an honor. Let's stay in touch. If you have, guys, any questions, you would like to learn more about what we're doing and how we're doing it, don't hesitate to reach us out on hello@Genies.it. Look at our social media, or you can reach out to me via phone on WhatsApp. It's always going to be a pleasure to talk to you guys. And yeah, once again, thank you very much for your attention, and I hope you'll have a great session in the future. Thank you.